Okay, so we're starting a new chapter, and it's section 3-1. And the main gist of this chapter is that we're going to learn the basic parent functions, and we're also going to learn how to adjust our windows on our calculators to make sure that we see all the parent functions when we look at it, or functions if they've moved. So this first one is a linear, and it's pretty obvious why it's linear.
Why?
Because it's a line, right? So actually, the main parent function of this is just x. F of x equals x. Because this particular one has a slope of what?
1.
1, and it has a y-intercept of 0, so it's just x. So then it's been translated or rotated.
No, like what
If we move it up, then it's translated up. Like say if we made, it would be x plus 1 then, right?
And that would give us the. Oh, yeah.
Okay? But that's not what the parent function is. The parent function in this case is just x. Okay? So the second one is a quadratic. Can you guys guess what the parent function for this one's going to be?
No.
X squared.
X squared. Very good. Okay? This one's just x squared. There's nothing fancy. It goes through the origin. Okay? The next one is cubic. So it's going to be
X cubed.
x cubed.
And then the next one is, the square root of x.
Yes. So that one would look like this. So this is all for real numbers. I'm not doing imaginary. Okay, the ones on the bottom. This last one here is f of x equals inverse variation. So this is going to be, or just 1 over x, k being 1 in this case. The inverse square is 1 over x squared. The absolute value should be something like this. And then this one's 2 to the x. Okay? So the reason I'm giving you guys all these on little note cards is because you do have a quiz on Wednesday on this. Either I will give you a graph and you will have to name that function and name the equation, or I will give you an equation, tell you to draw a picture of the graph, or I will give you the name and you will have to do the other two. So you need to be able to go back and forth. Yes?
We only use like one on this, or could you like put in different numbers?
Yeah, this is all just for the very basic with just a 1.
So on the quiz though, would you just use one?
Yep. Okay, so for this graph, we have the absolute value of x plus 25 minus 10.
So
One of the things I want to do is I want to graph this on a cast. So what I'm going to do, just a minute, I'll get to you, Moni. I'm going to actually go over to my cast. And if I were to put it straight in like this is the standard window. And notice, what does that look like?
it looks like linear.
Looks like linear, right? You can't see the whole thing. So to change your settings, you're going to go to menu first, and then you go to window zoom, and you go to window settings. And in this case, we know that it's way over. You can either guess and check until you get it in your window decent, or you can think about where it's located based on the translation. In this case, we know that it's to the left, 25. So I'm going to want to go over like to a negative 50. And I'm just going to leave my, I'm going to change my Y minimum because it says a minus 10 on it. So I'm going to want to go at least that far down. So I'm going to say minus 15. Oops. And then I'm just leave the rest. So if I hit OK, then you can see it on the screen. Okay? I did that earlier with a little bit different settings, and here it is with this one too. Okay? So the question on example 1 was, what is the domain and range of this? So what are the possible x values on this one?
The domain goes in between tribes that, or x that.
Mm-hmm. It's x such that x
Goes all real numbers.
is in all real numbers. You're right.
Yeah.
Okay? Okay, so that is the domain.
And then the range would be r parentheses y such that y, and then the little e thing is all real numbers, but then except, did it go down to 4 or something?
Well, let's look at it again. So where does it start at? Where is this point right here? Okay, so here's a big clue right here. See this minus 10? It's minus 10, yep. So this is going to be y such that y is all real numbers and y is greater than or equal to negative 10.
Yeah.
Okay? Let's look at the next one. The next one says to display the graph of the square root of x minus 8 plus 5 in a window that shows the graph's important features. So I'm going to open up a new page on this. I'm going to add a graph. And on the bottom here, I'm going to put square root. And I think I could just write it out like this. Square root of x minus 8 plus 5. Okay, notice, do you guys see it on the graph? It's hard to see, isn't it?
Is this little square root?
Yep, this is a square root.
Is it because it can't be negative?
Right, it can't be negative.
Does this what it should look like when it's square?
Yeah, it could, yep, or maybe it went a little bit higher on your graph. So if you change the settings on this, so if we go to menu, window zoom again, window settings, you know that your minimum should be at most, say a positive 5, and you might want to go up to a positive 20. And then your y should be all positive, so we'll just leave it at we'll do 0. Yep, that sounds good to me. 0.
And then go to like 20.
Okay, sounds good. We'll go to 20. Okay, so there it is.
Yay.
Okay. Notice that a square root, it has an ending spot, doesn't it?
Yeah.
Okay. So the ending spot is right here. So that means that, is it continuous for all x's?
No.
Is it continuous for all y's?
No. Yes.
No, because it starts right here. Okay, so let's write down the range and the domain for this one. The domain on this is x such that x,
All real numbers.
all real numbers,
And then x is greater than or equal to, what's that number? Can you go back?
it's 8.
Oh, 8.
Okay? Range is,
Y such that y, all real numbers. Y is greater than or equal to
what do you think from the equation? What do you think it'll be?
4.
5.
I'm close. Good.
Okay? All right, so example 3A, you do it kind of the same way. Basically it says, Stefan, who is 1.7 meters tall, dives off a 3-meter springboard. An equation modeling his height in meters above the water at time x in seconds is this. Okay? This is, you guys remember this from chapter 2. This is based on gravity and height, or initial height and initial velocity. Okay? So it says create a graph that would be helpful for determining the maximum height of his dive and how long it lasts. Okay, so back to the cast. If I were to go back and change this or get a new document, make a new graph. So I can put in here minus 4.9 x squared plus 4.5 x plus 4.7. And I have this. Okay, I have a question for you about this. Do we have negative time?
No.
So what should our minimum window be for x? 0. Very good. So I'm going to go and change my window settings to start at a 0. Okay, the max is not so bad. How about what should be my minimum y?
0.
0 as well,
Yeah.
because we can't go below ground on this. And then we'll just say
20.
y max will just stay at 10, okay?
Okay.
Okay. So there it is.
I don't hear it.
Okay? So this shows us he is at this point on the high dive. He jumps up, he gets to this tall, and that's the point that we need to find where he is.
Oh, then go to analyze graph. I got this.
You have this.
Oh, yeah. Go to menu,
Okay?
analyze graph, and then minimum.
Or a maximum?
No, 0, 0. My bad, 0. And then, no, start before. And then click it over. Click it. And what are you doing?
I don't know.
You
I'm
start
listening to
here.
you. Start here.
Yeah, you click it, and then, no, keep going. And
Okay?
then click it. Oh, go to those
You have to go to the top.
Wait, is that the minimum maximum?
So I think what we need to do is find the
I can do it on
max.
my computer.
Yep. There it is. There's the max. Okay.
It's supposed to go from the left to the right. That's all I know.
Yes.
Miss Seaver, you're done here.
Oh, did it? Okay, let's go back.
You gotta start over.
There it
Okay,
is.
now go to maximum. Oh, that's it. Okay.
Hold on a second. I want to turn this thing on.
What just happened?
Hold on. Okay. And then, so that's my domain based on the graph. We're not starting before 0 time. How about range?
Y such that y is all real numbers, and then y is greater than or equal to 5 or 6. 5.
Okay, now this is tricky. So y is less than what? 5.73 and greater than 0. So those are, it's bound by those two numbers, right? So on this one, it's going to be, y is going to be in the middle. I can say greater than or equal to 0 and less than or equal to 5.73. Oh, right, because x, yes, you should do it to x. Where does x end on that picture? 1.54. Yeah, so let's go back and change that.
So it's 1.54 is less than or equal to x, which is less than or equal to 0.
Right. So if I go back and change this, so we have 0 less than or equal to x less than or equal to 1.54. Because that's where the 0 is on the graph. Okay?
Okay.
How do I know I'm making a good graph? Well, the following things are important.
The x and y are
Yep, the axes are labeled appropriately with the scale shown. Okay? The window is chosen so that the characteristic shape of the graph can be seen. The intercepts are shown. Any endpoints are indicated as included. If it's included, it would have a solid dot. And if it's excluded, it'd be an open dot. Just like with greater than or equals or less than stuff. Okay? And then the last one is asymptotes. Are shown with dotted lines. The first one on the left is actually the same as the one on the right. It's just that the window is changed. And notice that the one on the left really looks kind of like a sine wave or a cosine wave. The one on the right shows you that it isn't. It's actually an x to the third.
Oh, it's just really zoomed in.
Right. That's why the windows are so important. Okay? So if you know what you are putting in, you notice that on this one, it's an x to the third. So that's part of the reason why it's important to know the parent function. You know if it's an x to the third, it's going to have something like this as a shape. Okay? So that's why if you know your parent functions, it will make your life quite a bit easier on this.